first thing we do is we set everything up. So draw your principal axis, straight line across the paper. Okay, draw your mirror. Yes. Draw your mirror. Now, this is a convex mirror. Convex mirrors bend the opposite way. So you're not going to bend it towards the left. You're going to bend it away from the left. I do. Ooh, yeah. Okay, then you're going to draw your vertical line. Okay. Then you're going to draw the object. So it says the object. It says the object is placed 2 centimeters in front of a 2 centimeter tall yak. Yakety yak. So we're going to draw 2 centimeters in front of the mirror. And write O for the object. We're going to draw it 2 centimeters tall.
So for the line on the mirror, it always goes towards the curved part?
Yes, it always goes on wherever the mirror, it goes away from the curve instead of towards, yeah. Okay. All right, the next thing. It says it has a focal length of 4. So a focal length of 4. Now here's where we got to be careful. The focal length is always on the side of the curve. So the focal length is not over here. It's on the other side.
Does it say 3 or 4?
4. Are you looking at the practice?
Yes.
The addendum, 2A addendum. So we need to put it at 4. That's going to be F. And then the last thing to do is C, which C is always double F. So that would need to be at 8. Should be here. So here to here is 4 centimeters, here to here is 4 centimeters. So we've got all the parts that we need. We got our principal axis drawn, we've got our object drawn, we've got our focal length, our focal point, and we've got C. Okay, so the 3 lines we're going to draw are the exact same 3 lines. So we're going to draw one line that goes straight and then through F. We're going to draw another line that goes through F and then goes straight. And then we're going to draw a line that goes straight through C. So here's where this gets tricky, though. The mirror is always going to reflect the light back. So you can't go through the mirror with the incident light, the light that comes in. You can only go through the mirror with the reflected light. And if you're confused on what I mean by that, this is what I mean. The light that comes in can't go through the mirror, but the light that reflects off can, because it's where it looks like it came from. So we're going to do the same thing here. We're going to have the light that goes into the mirror be a straight line. It reflects off the mirror, and then we'll reflect it off with a dashed line. So we'll do the exact same thing here. So first line goes straight and then goes through F. So we're going to start at the top of the object like before, and we're going to draw a straight parallel line straight to the mirror. Just like that. And then it's going to reflect through F. But here's where we need to be careful. Does the light actually go to F?
No.
Good, you're correct. It does not actually go to F. So it's going to reflect back the way, back on the opposite side. Now, you backtrack it through F. But it's going to look something like that. So it backtracks through F, but it doesn't actually go, it reflects back the way, back the opposite direction, but you backtrack it through F. Okay. Second line. Second line starts going through F and then reflects parallel. So we're going to line it up. We're going to line up the object and F. And we're going to go to the mirror. But here's the thing. You have to stop at the mirror. Notice I didn't actually go all the way to F. I lined it up with F. But before I could get to F, I hit the mirror. So I stopped where I got to the mirror. And now I'm going to reflect it parallel to the principal axis. And backtrack that line. Okay? Anyone need a little bit more time to get the lines? Okay. I'll give you a minute here. So we only got one more line left to draw. All right, last line. Last line goes through C and then reflects straight back on itself. So we're going to line up the object with C. We're going to draw it straight to the mirror. Again, when it hits the mirror, it stops. But this one's different in that it reflects straight back on itself. So it reflects straight back. And then backtrack it through the mirror. And then you're looking for where do they intersect. And you can see mine all intersect here. Now, most of you are going to have a triangle, right? Most of you are going to have a little triangle. Nope, yours is perfect.
I don't have a triangle this time.
Perfect? Nice. Will, is yours perfect again? Nice. Okay, so wherever they intersect, you're going to draw a straight line from the principal axis up to that point. So line them up. And then we're ready for the three things. Now, on here it says magnification. You can cross out magnification. I'm not going to make you do that for these problems. So we need three things. We need,
Height.
we need the height of the image. Here, let's do it in the same color. We need the height of the image. We need the distance of the image. And we need the type of image. So the height of the image is very straightforward. You just put your ruler up there. And again, measure it to the nearest quarter or so centimeter. So here's 1.5. So mine's 1.5. That's my height, 1.5. If yours is a little bit more than a half or a little bit less than a half, then you might call it 1 1/4 or 1 3/4. DI, I'm going to measure that one also. DI is in between. So 6 to 7 is 1. And then it's in between 7.5 and 7. So I'm going to call it 1 1/4. So 1.25. and then the type of image is looking at what image type is created. So we said this is really easy to figure out. Everything to the left of the mirror is where light actually exists. See how I drew my arrows bouncing away? That's the real light. Do those intersect anywhere over here? No. They intersect over here, so it's virtual. Yes.